You are looking up at Orion. 3 stars mark his belt. 1 shoulder burns red. That red light left its source over 500 years ago. It had been traveling toward your eyes since before Christopher Columbus crossed the Atlantic. And the star it came from might not even be there anymore. That star is Betelgeuse, and it is dying. What happens when it finally goes? Would the sky burn? Would Earth survive? Betelgeuse is a red supergiant, a star so bloated with age that if you place it where your sun sits, its surface would swallow every planet out of Jupiter. It sits roughly 548 light-years away, in the shoulder of the Hunter. A light-year is the distance light travels in 1 year, about 9.5 trillion kilometers. So the number 548 isn't just a distance. It's a delay. It's a message 5.5 centuries old, still arriving. Stars like this don't fade quietly. They run out of fuel to fuse in their core, and when the fusion stops, gravity wins. The core collapses in less than a second. The outer layers slam inward, then rebound in a shock wave so violent it tears the star apart. Astronomers call this a core collapse supernova. For a few weeks, the explosion can outshine an entire galaxy of 100 billion stars. Betelgeuse is a strong candidate to do exactly this. Not in some distant epoch, possibly within the next 100,000 years. On a cosmic clock, that's tomorrow. In late 2019, something strange happened. Betelgeuse dimmed. It lost about 2/3 of its usual brightness. And for a moment, headlines everywhere asked if this was it, if the star was finally collapsing. Astronomer Andrea Dupree of the Harvard-Smithsonian Center for Astrophysics used the Hubble Space Telescope to look closer. What she found wasn't the beginning of the end. It was a massive cloud of stellar material, likely a piece of the star's own surface, ejected outward and cooling into dust, briefly blocking its light. Ground-based observatories, including the European Southern Observatory's Very Large Telescope, confirmed the star's surface had also cooled unevenly, creating a colossal dark patch. Betelgeuse wasn't dying. It was shedding, like an old giant losing a piece of skin. But the event proved something important. This star is unstable, restless, and unpredictable in ways scientists are still working to fully understand. So picture it. Picture the night this finally happened for real. For weeks, nothing looks different. Then, over the course of a single night, a new point of light brightens where Betelgeuse used to sit. Within days, it rivals a full moon. It is visible in broad daylight. It casts a second, fainter shadow at night, right alongside the shadow the moon makes. This isn't fiction. Human beings have witnessed this before. In the year 1054, Chinese court astronomers recorded a new star bright enough to see in daylight for over 3 weeks. That explosion left behind the Crab Nebula, a glowing wreckage of gas still expanding today. Studied for decades using telescopes ranging from Palomar Observatory to the modern James Webb Space Telescope. But here's where the story turns. Before any of that visible light reaches you, something else already arrived. Years earlier, in fact. When a star's core collapses, it releases a staggering burst of nearly massless particles called neutrinos, so ghostly they can pass through an entire planet without slowing down. In 1987, a supernova named SN 1987A erupted in a neighboring galaxy called the Large Magellanic Cloud. Hours before the light became visible to human eyes, underground detectors on Earth, including the Kamio Candy 2 experiment in Japan, register a handful of neutrinos passing straight through the planet. It was the first time humanity detected a signal from a dying star before we ever saw its light. If Betelgeuse explodes, the same thing will happen. A flood of neutrinos will wash through Earth, through you, through every atom of this planet, hours before the light show even begins. You wouldn't feel a thing. And that leads to the twist most people never expect. Would this actually hurt Earth? No, not even close. Astrophysicists estimate that a supernova needs to occur within roughly 25 to 50 light-years of Earth to meaningfully damage our atmosphere, stripping away the ozone layer and exposing the surface to harmful radiation. Betelgeuse sits at 548 light-years. That's more than 10 times the danger distance. From here, Betelgeuse going supernova would be one of the most spectacular events in recorded human history, and almost entirely harmless. A new light in the sky, brilliant enough to read by at night. Gone within a year or two, its glow fading as the expanding debris cools and thins, eventually leaving behind a supernova remnant and likely a dense stellar core called a neutron star. Here's the part that should genuinely unsettle you. Because of that 548-year delay, nobody actually knows if this has already happened. The light you would see the night, it happens left Betelgeuse over 5 centuries ago. For all astronomers can currently confirm, the star could have already collapsed sometime around the year 1478, and Earth simply hasn't received the news yet. Every clear night, when you look toward Orion's shoulder, you might be looking at a star that no longer technically exists, only its ancient light, still finishing its journey across the galaxy. This is the strange truth astronomy keeps handing back to you. The night sky is not a photograph of now. It's a patchwork of different paths, layered on top of each other, each star's light arriving on its own delay. The sun you feel on your skin left 8 minutes ago. The North Star's light left over 400 years ago. Betelgeuse's light, left before the telescope itself, was invented by Galileo Galilei. Carl Sagan once described looking at the stars as looking back in time. He was right in a way that's almost dizzying once you sit with it. Every time you glance up, you're not seeing the universe as it is. You're seeing thousands of overlapping messages, each one a little more out of date than the last, all arriving at once, all pretending to share a single moment that doesn't actually exist anywhere except in your eyes. So the next clear night you get the chance, look for Orion. Find the red star on his shoulder. Somewhere between now and 548 years from now, that light will change forever, and you may never know exactly when it started. You are looking up at Orion, and you are not just seeing a star. You're seeing a message from the past, still deciding, somewhere out there, whether it has already ended